So it's my real pleasure today to have Kurt Waldman here. And Kurt is an assistant professor in the Department of Global Development here at Cornell. And he studies judgment and decision-making related to environmental sustainability, climate adaptation, and food security. To do this, he uses quantitative methods from behavioral experiments, econometrics, and through integrating social and environmental data. Kurt received his BA in history from Ehrman College. He spent time in the Philippines in the Peace Corps, and he spent some time in Afghanistan with the Catholic Relief Services. He received an MS here at Cornell and applied economics, PhD in sustainability from Michigan State, and he came to Cornell about 2 years ago from a faculty position at Indiana University. So welcome.
All right, so today I'm going to talk about the influence of extreme weather events on farmer behavior, and this work is all in Zambia. I've been working in Zambia for a number of years, and Zambia is a very arid country and has a lot of extreme weather events. I'll get into that in a moment, but I should explain first of all. I'm on the one hand, a behavioral scientist, so I started in behavioral economics and I moved more towards social psychology, really just out of this interest in understanding how people actually think. I think in a lot of ways, well, some of you are probably economists in the room. Economists tend to make a lot of assumptions about how people think. Behavioral scientists and cognitive scientists are much more interested in understanding how they actually behave and observing their behavior and studying the processes that are underlying that. Thank you, appreciate that. And then I'm also, on the other hand, a geographer. I was in the Indiana University Geography Department for a number of years before I came here, and I'm really interested in human-environment interactions. And as you'll see in this talk, I'm constantly trying to figure out how do we essentially match this observational data with this social science data. So how do we connect information about precipitation events with how people are actually observing, experiencing, and thinking about precipitation? So the work I'm going to talk about today is funded by the National Science Foundation. It's actually from a program, Human Environment and Geospatial Sciences, which was doged. So it no longer exists. I guess they're still paying for my project, but if the screen goes blank and somebody like carts me out of the room, I guess that may be, the end result of this program being disbanded. I'm not sure why. I guess they don't like climate change. We can discuss how controversial this is at the end. All right, so I'm going to give you a little bit of background about Zambia and the rainfall and climate context there, and then I'm going to talk about our work analyzing extreme events and pairing these social and environmental data types. And then I'm going to talk about the challenges that we have between doing this. How do you match perceptions with observational data? And then this last part is my team is building a software application to be a decision support tool. So essentially a tool to aid farmers in thinking through how to navigate weather changes. All right, so in a lot of ways, Zambia is ground zero for climate change. So arid parts of the country are supposed to be most impacted. Climate change is disproportionately affecting small farmers in developing countries, and maize production is supposed to be most impacted. Any guesses on why maize or corn is supposed to be more impacted than other crops? It's just a more sensitive crop to temperatures and moisture levels than other crops. But if you look down here in general, you'll see that the southern tip of Africa is expected to have as much as a 20% decrease in crop yields over, I think this paper was over the next 15 to 20 years. And then this is Zambia here, and I'll get into the details of that in a second. So when we talk about weather uncertainty, It really matters in this context because these farmers are not irrigating their fields. They are just depending on rainfall for production. There's very little irrigation at all in Zambia. If any, it is commercial agricultural production, which is a very small part of the overall sector. And then they have a distinct wet, dry season. Really, it rains for about 4 months in any given year. And in that time, farmers essentially have to, that is the entire period that farmers have to grow their crop. And then there's frequent drought events and dry spells, and I'll tell you more about what those look like as we go on. So here's a cutout of Zambia. 75% of the grain crop is maize in Zambia. This is mostly just for household subsistence. They are eating maize as a porridge or a well, it's a very dry porridge. It's more like the consistency of cream of wheat. That's sort of, you could pick it up in your hand. And so they, as I was saying earlier, like they need to actually produce enough in this 3-month period to last them throughout the dry season. So there's a lot of pressure to really get a yield that is sufficient for the entire family that may allow you to generate a little bit of income if you need to sell it, and then to last as food reserves. It really sort of raises this bigger question I'm getting at here, which is, what you plant and when you plant it is really critical. All the management decisions around production are very important. The bigger context here, so hybrid maize varieties were, hybrid varieties of crops were developed, as early as like the 1960s. You really didn't see hybrid crops getting to parts of Africa until the 90s. In 1990, the seed market was liberalized, which essentially meant, they went from having a single government-owned company, Zamseed, producing all the maize for the country, all the maize seed for the country, to allowing in lots of different firms. So you started seeing other Zambian companies, but also national and international companies coming in, and the number of seed varieties all of a sudden jumped up to 20 varieties per year. So farmers are really sort of swimming in seed varieties. Many of these seed varieties persist on the market for several years, as much as like 15 years before they go out, before they're no longer effective. Along with this has been this hybrid seed and fertilizer subsidy program. So basically in every single year, farmers are getting free hybrid seed and free fertilizer from the federal government, the national government. This is also paired with a weather index insurance most recently, but 80% of farmers don't even know they have this index insurance, which isn't a good quality if you think about the point of having insurance. So in a lot of ways, it's a situation where they're just awash in these hybrid seed varieties now. Here's a couple images of what this. Sorry, I'm not staying within the confines of the camera. Here's a couple images of seed packages, but essentially what I want to communicate is that there are not very many. So there's fixed agro dealers across the country. This is where you would purchase your seed. There's as many as 20 different varieties in every given year, 20 different companies producing approximately 10 different varieties now. So you're potentially facing a couple hundred choices that you could purchase. Not all of them are available at every seed distributor. So if you go into really rural areas, into a small village, you might just have 5 choices or something like that. So farmers are constantly trying to figure out information about the seed varieties, but there's no real regulation around it. The seed companies don't put information on consistent information on the packaging, and so farmers are left to guess or speculate or just talk to their neighbors and friends and figure out what is out there and how that might differ from some of the other varieties they've been planting. through this federal input support program, the free fertilizer and subsidy program I mentioned before, farmers now get e-credit. So they used to just get a seed variety just sort of sent to their local cooperative, and they didn't have a lot of choice. It wasn't well targeted to where they lived. They essentially just planted whatever they were given. Now they have a little bit of choice through this e-voucher program where they can buy them from distributors, but it's not a perfect program. They've really suffered from a lot of poor rollout and technical issues around this e-voucher system. So people getting the cards late, people actually getting money on the cards late, which, as you can imagine, is super critical. I was just telling you that one of the most important decisions is when you actually put your seed in the ground. So here's a map of Zambia with a rainfall gradient put on top. So this is just basic precipitation data from the last 20 years. But what you can immediately see is that there's a very dry area on the bottom, and you've got this sort of diagonal where rainfall increases up into the north and west parts of the country. This is important because this is essentially dictating what types of seed you can purchase. What I should have mentioned on the last slide is these seeds differ in several ways, but the most important thing is when the seed matures. So what's happening now is these seed companies are just developing earlier and earlier maturing varieties. If you live in the really dry area in the bottom, you would think that what makes the most sense is to just plant the most early maturing variety. And the same with as you go up, you can plant a slightly later maturing variety because your actual growing season is increasing in the number of days. But it's actually a lot more complicated than that. This is a bunch of aggregated seed company information from a few years ago, but this is probably about 100 different seeds by all of the companies that I was mentioning. But what you can see here is that there are several of them who actually have sort of overlapping estimates of the maturity date. So you can buy a seed variety with a 115-day maturity period that could be labeled very early, or medium. And so there's not a lot of consistency in how the seed companies describe these varieties. And it's really confusing to farmers. They don't know that medium means the same or something different from one firm to another. The other key idea here is the earlier it matures, the less yield you're getting out of it. So if you're planting one of these late maturing varieties that's supposed to get about 13 tons per hectare, you're going to get almost twice as much yield as you could with these early maturing varieties. So there's this real trade-off. What the seed companies are trying to do is help them cope with risk, to have a shorter growing season, shorter amount of time exposed to this rainfall variability, but what you're giving up is yield in that process. And then naturally, the other component of this that varies is price. So the later maturing varieties are more expensive than the other varieties, in part because they have this higher yield potential. Traditional varieties in Zambia, so before they really had this onslaught of all these hybrids coming onto the market, really took about 5 to 6 months to mature. And this is the same case with these late maturing varieties now. So you can imagine if you're back in this really wet part in the north and west, you'd really do well to plant the late maturing varieties because you can get a lot, quite a bit more yield theoretically. The reality is quite different, though. So this is a box plot of each of the different variety types. So early, medium, late, and early, medium, and late maturing, and then the local varieties. And what you can see is that, well, the first thing to notice is that they're all sort of hovering around 2 tons per hectare, when many of these seed companies were just telling us that you could expect 7 to 13 tons per hectare. So very few people are getting anything close to the to the estimates that that the seed companies are telling them they could potentially get. There is seemingly a little bit of benefit compared to the local varieties, which essentially is just reusing the seed that you planted from last year. Some people are getting a lot of benefit, but the majority of people are just sort of stuck in this middle where it almost doesn't matter which one of these different types you're planting. And a lot of this is because of when they're planting, and we'll look into this in a little bit more detail. But the gist here is that yield comes down to what you plant and when you plant it. And farmers don't know the climate data. So this is really what we're trying to unpack in this project. And from a cognitive scientist perspective, we call this a problem of bounded rationality. We can't make this fully rational decision if we don't have all of the relevant information. So moving on to the process of essentially answering this question, which seed varieties to plant and when to sow them, requires us to essentially define extreme weather events and think about how people process these events and how people remember these events. So in some ways, what we're exploring here is known as the availability heuristic. So there's all this information out there I potentially could use to make any given decision, whether it's, what do I want to be when I grow up? What class do I want to take, et cetera. But what we actually do is just use a tiny bit of information. And we often are just using information that is salient to us in some way. So it's either recent, we frequently heard of it, it's a negative event, so it's stuck in our head for that reason, or an extreme event. So there's lots of different ways our brains are actually quite bad at sifting through information. And this is something we're trying to unpack in the weather data. So we use two different kinds of environmental data here. This first set is precipitation data. So the climate hazards group, infrared precipitation with station data. It's basically just remotely sensed precipitation data. It goes back about 30 years. The station part of it means that they're just taking any sort of meteorological stations that they can get access to in Africa and integrating them into their current model. CHIRPS is in a lot of ways sort of the gold standard for doing this kind of weather and precipitation work in developing countries. They've developed it for parts of the world where we really don't have good weather information at all. As you can perhaps imagine, we have, say in Texas, we might have like 250 weather stations. In the country of Zambia, you may have 7 that are functioning at any given time. So there's not a lot of weather information to draw from. And so these remote sense products become really important. We're also using Sentinel-2 satellite data for the yield and vegetation part. And I'll talk a little bit about the types of data we're using here. But this is a very high resolution data product, which has a lot of flexibility when we want to look at crop data in particular and crop type. And then the social data comes from some work we did last summer. So we spent a couple months moving from the south to north as the growing season was ending, interviewing farmers. We interviewed about 630 farmers. And when we were at each farm, we also took a GPS unit and walked around the boundaries of their farm. And so we have a really precise indication of where their farm is. And then we also did crop cuts, which are essentially taking a 4 meter by 4 meter plot in the center of a field and harvesting it with the farmers. And then we weigh it, control for moisture, and have this sense of, a pretty accurate sense of what yield looks like in that field. I'll talk about it a little bit more, but basically we're doing that to calibrate these remote sensing models. All right, so the other thing we have here is and what we're trying to do is identify extreme weather events with the precipitation data. And there's 3 main things we're interested in. So just basic precipitation variability, dry spell frequency and drought, so the length of them and how often they occur, and then growing season length. This really would dictate, moving from a sort of theoretical to more concrete picture of what kind of variety can you support, how many days maturity can your area handle in terms of maize variety. And then we're looking at this on sowing date and seed type, and ultimately trying to predict yield outcomes from this. And these two decisions of the sowing date and the seed type are what we really are, I want you to hang on to here. Oops, sorry, that was a little grainier than I hoped. So what this figure is showing you is how we're trying to identify the actual growing date from the remotely sensed data. So we're essentially looking at this inflection point when all of the weeds are removed from the prior season, the soil is bare, and then they're planting and having crops mature again. And this also allows us to grab a signal for essentially what crop variety it is. It's allowing us to determine how long the maturity period of this particular maize variety is. We're really good at predicting very well irrigated farms, which, as you probably recall from earlier in the talk, is not what we're typically looking at here. So anybody know why these farms are circles? Yeah.
The water, they just use their own, right? But just the water they don't circle around.
Yeah, so these aren't like small farms that are unirrigated. These are what's called pivot irrigation. So they're these big circular fields that are irrigated from the center of the circle. And so we can find those really well, and we can identify the dates of those really well, but it's much harder for the small farms. And I'll show you a picture of that in a second. And then what we're doing with this, and then for the yield estimation, we're using this green chlorophyll vegetation index, which is a 15-day time series, and we're training a random forest model off of this. And the way we're doing that is using these crop cuts. So this is the measured 4-meter by 4-meter plot in people's fields, and predicting it and predicting the GCVI yield with it. So we're really just trying to calibrate, is this model consistent with this hard work that we did in the middle of the fields, pulling out and weighing the maize. And we do it in two ways. We're doing it for some of the. So this is a picture of some of the fields and the field boundaries we have. If you see, there's sort of small circles that are all in the line, and that in that field, farmers tend to just pile their maize up like this right after they harvest it, and they let it dry out for a little bit. But as you can see, we have really high precision data, and we can really see what's going on their farms. And so we're really just trying to make this connection here. But so with the sample where we have the actual field boundaries, and we took all the yield samples, we're using that to do one part of the analysis, and then we're using that trained model from that part to then make projections across the whole country. So we can then sort of look at what extreme events are happening, and how is that changing farming practices. All right, so the big conceptual thing we're wrestling with here, so moving on to really just kind of matching and pairing the social and environmental data, is there's a lot of studies that, ever since we started using remote sensing to understand agricultural problems, particularly in developing countries, we've seen instances where people are using it to corroborate data that they have on the ground, or to try to get a more accurate picture. And a lot of times what we see with even something quite simple, like estimating field size, we don't do it very accurately, right? So we're able to, this is a pretty objective thing, right? Just walking around the boundary with a GPS unit that'll tell us area. But farmers are constantly on the lower end of the spectrum, really overestimating how big their field size is and underestimating it on the upper end. Any ideas why this might be the case? Yeah.
Say bad with like large numbers, that probably translates to distances as well.
Yeah, yeah, exactly. I mean, and also like these farmers are not used to using the same metrics that we're using. You know, there's some of these small fields really are so tiny that they're, you know, they probably just round up to a half of a hectare or a quarter of a hectare for practical reasons, right? So it sort of makes sense that there's this mismatch there, but it's problematic, right? If we are trying to talk to farmers or doing analysis based on a farmer's field size, but they perceive their field size to be different than we are modeling it, it really matters because we're not capturing exactly how they're thinking about the decision-making process. We see a similar thing with maize harvest. So this, at the end of the season, a truck will essentially come in with these, well, with brand new bags for them and a big scale, and farmers will all pack their harvest into the bags and bring it out to be weighed. You know, this is for the stuff that they're selling. And what we find is that the yield sort of follows a similar pattern where we often are just measuring, we're also often capturing farmers constantly overestimating their harvest on the lower end and then underestimating it on the larger end. So for bigger values, it's just a little bit fuzzier. There's a lot of sort of frustration in the agricultural economics community about this. They tend to refer to it as measurement error. But what I'm getting at here and what I hope I'll convince you of is a lot of this is just conceptual mismatch. Like we're often asking farmers to just think about things on our terms that don't use the same sort of mode of weighing things or measuring things. And so we're sort of lost in translation here. So turning to the environmental data, and this is sort of what our group is trying to solve now, is looking at something like the number of dry spells. So this is the number of dry spells reported by these 630 farmers. You see that most think that there's or observed 2 or 3 dry spells in the past season in their minds. But when we use these common metrics, if through remotely sensed precipitation data, so the FuseNet group is the Famine Early Warning System network. I heard they were getting doged too. I hope not. They do some pretty important work. But so they work with this chirp state as well, and they use a metric that they came up with that they feel like is a pretty good predictor of famine in their eyes. So 5 or more days with less than 4.2 millimeters of cumulative rain. But what you see is when you overlay their metric onto farmers' responses, it doesn't quite capture the precipitation or this expectation of a dry spell in the same way that farmers do. If we turn to another definition, which is this is more of an agronomic definition, looking at 7 or more days with less than 0.5 millimeters of rain a day, you see we start to sort of fill out the picture. But this is problematic, right? Because if we choose, you know, if Famine Early Warning System is basically making all these projections based on their calculations and their metric, but farmers are thinking about it in a sort of broader set of heuristics, then there's a real mismatch there, and we're potentially not capturing their decision making well. This final example is on growing season length. This is the number of days that the farmers estimate their growing season to be in the past season, relatively normal looking distribution. When we use what is often referred to as an intuitive definition that many farmers use, so basically the first day with heavy rainfall, we're defining heavy as more than 5 millimeters. We see that we're actually very conservatively predicting the season length, and it doesn't represent the full breadth of farmers' estimations of what season length looks like. And then here again, I'm adding more of a hydrological definition. So this is sort of a post hoc definition, but after 10% of the rainy season, of the rain has fallen during the season, up until 90 has dropped, we see we get a different distribution, right? So the season length is quite different with that metric. And then finally, using another agronomic one that's common in the literature, we see that we're now actually capturing the breadth of farmers' responses, but it really matters, right? How we think about this, the observational data. Something my group has worked on in the past is essentially translating farmers' heuristics, so getting them to tell us, how do you categorically, like how do you think about rainfall? How do you think about when the season starts? And then mapping that onto precipitation data. So using that heuristic to essentially come up with a rule to sort of operationalize and integrate the observational data with the social data. And what we've been able to do is really accurately predict something like rainy season onset. So this is an older paper, but in 2015, when we actually use these metrics, we can get the data to line up quite well. As I'll talk about a little bit later, the problem with that is like you can get really exact in terms of conception, but then farmer recall gets really messy. And so there's quite a bit of divergence when you go back in time. But so this is sort of the big picture on how to conceptualize and how to match these two kinds of data, something our group has been working on for a while and is now developing a software application or a decision support tool to address. So as you can imagine with a lot of things, whether there's this trade-off, right, between how simple it is, how simple something is to understand, and then how much information you can pack into it. So if you're a computer programmer, for example, there's a lot of different trade-offs you might imagine, but what is the user-friendly, what is the balance between something being sort of user-friendly and also having a lot of information or enough information to actually aid a decision. And that's what we're wrestling with here, this more conceptual problem, which is like, okay, if I'm going to project all this precipitation data to farmers to give them data that really sort of like matches how they think about precipitation, where is the trade-off? Like when is it too complex to actually be useful to them? And then where is it like too simple? When is it just not enough information to be useful to them? So some requirements that we've identified from talking to farmers and doing this work is it has to be really high resolution. So a lot of the global climate models suffer from this, and they've been increasingly getting finer granularity, but rarely is it field level granularity, which is what we're trying to achieve. And then being focused on a specific decision. So keeping in mind that work on the extreme weather events and keeping in mind how important sowing date and seed type, so when to plant something and what to plant, as these decision nodes that farmers have, how can we essentially craft the information to those decisions? A lot of global GCMs, for example, are just giving somebody a projection about whether it's supposed to be a good year or a bad year. But how can we really kind of like craft it around a specific decision point? And then also, how do we communicate about uncertainty, right? So there's a whole field essentially devoted to this topic, and this is something that cognitive scientists think about a lot. But how do we create visualizations? How do we communicate with people about this very complex thing in a way that's useful to them and easy to access? And then the final part of this speaks to this sort of mismatch I was just getting into. How do we capture subjectivity? How do we capture that one farmer thinks about and plants his crops after a single day of heavy rain, whereas another one really waits for full saturation and looks at the soil moisture, picks up a handful of soil and sort of mashes it around in their hand to gauge the soil moisture. So with these criteria in mind, we started developing this tool with some students in the informatics department. And we expanded to So this is Zambia, but then we've also are doing some work in Malawi with some other colleagues. And so I'll talk about that in a second. This is where we're going to pilot some of this software application this summer. But what we're doing is essentially pulling through an API data from this CHIRPS website, so that that precipitation data, and they can go back several years in time and look at, essentially look at what the data looks like at their specific geolocation. So we're using a bounding box now, but if you're in Zambia, it'll just geolocate exactly to your farm. So you can choose the number of years you go back. And then we also are trying to capture the subjectivity. How many days is a dry spell? So do you think it's 5? Are you like knowing your soil conditions and the crops, the maize variety that you've been planting? Is it more sensitive? Is it 5 or is it 7? And so letting farmers sort of create this, tailor this tool to their own heuristics and decisions. And then the same thing here. When does the season start? So again, trying to get at this heuristic that really speaks to when they feel comfortable planting and when they, gauge the season to actually start in their area. And so once you select these different parameters and hit go, it will provide you information in a couple different formats. So one is just a typical table format. Much of the communication from the government about weather at this point comes just in tables. And so some farmers may prefer tables. We also are going to produce these basic bar graphs. So this, well, I guess this is these basic line graphs. But so what this is showing is a few different pieces of information, which I'll unpack in a second. But really just kind of getting at this general idea, like what is going to be the most useful to farmers? Do they want to know the approximate sow date based on their heuristics? Are they worried about when the dry spells occur in the season? Or do they just want all the data? So this is essentially just the total amount of rain in every given year, when it occurred and how much occurred. Just looking at this, does it seem easy to you to decide when the optimal time to plant is? Or how long the growing season is? Not really, right? Like this is basically like raw data. We have to process this a bit for someone to understand it. But they also might like to look at this to essentially calibrate what we're showing them with what they experience to verify that it's correct. So what we're doing this summer is testing these visualizations. So testing this sort of balance between what's usable and what's both usable and what's an appropriate level of complexity. So this is essentially deconstructing that figure I showed earlier, where the blue lines are the season length, the green dots are rain onset, the orange bars are with drought periods, and then these colored bars are essentially indicating what the frequency of the drought occurrence is across the data set, across the number of years you've selected. So as you can see, like the first graphs are probably not that useful. You kind of need some of the drought periods to make any sense of it. But then the frequency may be kind of confusing to some people, depending on how fine the data is or accurate to your farm, it may not be that useful for you. So we'll be having farmers essentially wade through some of this and think about what is useful to you, what do you want, what would you like to see, and then we're going to integrate that into what we're doing. But really what we're trying to get them to do is evaluate these figures against each other. And so using this tool that's common in marketing called conjoint analysis, we essentially get them to evaluate, like, is this figure A better than figure B? Why or why not? And so what we end up with too is, so we'll have them rate essentially how easy something is to understand, the complexity, and then how usable it is. And we'll be able to plot each of these different types of figures across the plot, and then look for clusters. Like, so maybe there's some understanding about, or there's clear identification of one type of figure. So the yellow, for example, is the final figure that has all the layers of complexity. Like, is this figure, the most useful, and, people don't find it too complex? Essentially, what do these clusters mean? What sense can we make of this? What can we learn about scale? Is it that, women farmers tend to prefer a certain type of information more than male farmers? This is really just sort of mock data telling you, just trying to describe how we're evaluating the visualizations against each other. And so we're piloting this data this summer in Malawi with some farmers there through focus groups. So essentially just talking through some of these sort of usability, comprehension issues, trying to figure out from them what types of data will be most useful, and then testing the visualizations that I was just describing, and really focusing on the decision points. So kind of creating an environment where farmers can tell us through different means, like what way of expressing climate uncertainty is most useful to you. All right, so just wrapping up, as I've sort of mentioned, there's this, in a lot of ways, farmers struggle with global climate models because they're not granular enough and they're not focused on decisions. And so we're trying to take this much more sort of stepwise approach to building weather data up. So just most recent weather data, and trying to get essentially create visualizations that speak to farmers' needs, rather than looking at climate models that go farther into the future than farmers are interested. Also capturing the subjectivity in the observational data, so letting farmers choose what types of figures they would like to see, letting farmers articulate what their particular heuristics are, and essentially in the process trying to understand biophysical concepts on farmers' terms. And then ultimately developing framework and tools for communicating about weather uncertainty with farmers. So what are these? We've taken a look at many of the things that are out there, and there doesn't seem to be anything that's quite meeting all of these requirements that we're hearing from farmers, and observations that we're having about matching farmer data and observational data. And so, what do these next generation of decision support tools look like? All right, I am going to wrap it up there, and I'm happy to take any questions.
Thank you for the presentation. I was wondering, sort of, a lot of what you focused on was taking a look at how the perception of farmers was affected and could be compared to real data, whether that would be drought conditions, whether that was the length of the season. Was there any attempt to change their perception intentionally, like using the data that we have, for instance, that is probably better over the course of many years on precipitation, for instance, in order to say, well, it is actually better to consider the start of the rainy season after X amount of time, or after this day, as opposed to kind of just defaulting to whatever they think is best, or no?
Yeah, I mean, I like that. I like that question. I mean, in a lot of ways, there's this long history in development of researchers and development practitioners essentially just sort of coming in and saying, like, here's how you should think about this problem. And in response to that, there's also now a sort of big movement around, how can we do participatory work? How can we kind of make things align with, farmers' interests a little bit better? And I'm trying to sort of hit this sweet spot where I'm like figuring out some information about farmers' cognitive processes, but then I'm also interested in understanding cognitive biases. So if somebody is, essentially misremembering when the rainy season started, or they're, using a cognitive anchor of a certain date that their forefathers always planted, then that's a problem, right? So then, they're not adapting to climate change. And so a little bit of, I sort of move in between these two sort of areas of study in a way to have some validity. I think if you're just sort of critiquing farmers' biases, you'll get a lot of critiques. If you're just sort of developing stuff that's coming out of, their perceptions, then you're actually potentially missing some valid information. And so, yeah, this is actually one of the a separate project we're working on is really kind of getting at like how, in what instances are farmers sort of misremembering things, and if we push climate data to them, like does it change their decision-making structure? And this tool is one way to kind of create infrastructure to do that. Yeah, go ahead.
So, thank you so much for your talk. It's really interesting. So my question is, to what extent is the difference of formal heuristics and scientific metrics as a result of cultural differences? And how does your team would communicate and address that?
Yeah, I mean, I've been sort of this is another very good question. In a lot of ways, some of my motivation has come out of seeing like basically this long history of agricultural economists engaging with farmers, and having been trained in agricultural economics myself, I'm guilty of this as well, but really kind of like not being on the same page. And I've been shouting quietly in the field about like, hey, this is a problem. Like we shouldn't just be like assuming that farmers know their field size. Like this is, one could, economists tend not to like to talk about culture. You could say it's cultural. It's also like we don't use the same metric devices. Like they're not out there measuring things like economists and scientists are all the time. And so how do we kind of create study the problems that are impacting them using language and sort of a mindset that reflects theirs a little bit better?
Hi, Professor. Thank you so much for your talk. I remember in one of your studies, you mentioned had collecting interviews of more than 600 farmers. How were you able to manage the vast quantity and also the variations between these interviews and make predictions towards the whole state? Thank you.
Yeah. Yeah. So one of the things that we do is try to be very intentional about where we actually conduct the surveys. And so um, if you look at this figure here, you're not looking at that figure there. So if you look at this figure here, like we very intentionally sampled along this rainfall gradient. So we're trying to capture like different experiences with rainfall because we know, for example, like there's way more extreme weather events down here than there are up north. And so and also like there's parts of the country like out here where there just is very limited populations. Like in a lot of ways, this sort of belt up the diagonal is where most of the population lives. But yeah, I work with the University of Zambia and colleagues there, and we really sort of try to pinpoint areas that make the most sense based on the precipitation data, and then go in and sample people who've been, who are sort of falling within those areas and outside of those areas to kind of get, make sure we're sort of capturing or stratifying across the precipitation gradient more than anything else. But it's complicated. There's lots of different dialects in Zambia, and so we always have this process. We tend to have like 7 or 8, usually master's students helping us do all the interviews. But there's all these like ethnic tensions that we're not fully aware of, or somebody speaks multiple languages, but not the language that's Tonga that's spoken in the southern province. And so we really have to like carefully kind of find the right teams, and it's always a bit tricky.
Hi, Professor Waldman. Thanks for your presentation. I was wondering, how do farmers in Zambia perceive this climate tool, and what kind of challenges do you think for scaling up this decision-making tool?
Yeah, the first part is easy, so they don't perceive it at all yet. We haven't really worked with, actually, that's not true. I taught a class a couple years ago where a group of students from when I was at Indiana University worked with students from University of Zambia, and they basically like came up with the early version of what some of the tool would look like. And they worked in focus groups with farmers to kind of get some feedback on it. So a lot of our work came out of that, and we're sort of trying to build it up from their interest. And then what was the second part? I mean, the biggest challenge is cell phones are ubiquitous in Africa, but they're mostly, for lack of a better term, dumb phones, like flip phones, et cetera. They're not smartphones. And so, most of what we're doing is not something that could be like immediately pushed onto a farmer's phone and they could just be playing around with it to make a decision and talking about it with a colleague. A lot of it is sort of like, here's a tool for agriculture extension to go work with farmers with, or NGOs. But outreach is tough in this kind of, well, in this huge country with very little funding in the agriculture extension sector. And so it is a challenge. In a lot of ways, we're trying to like develop something that will be usable into the future, or something that is essentially usable by extension officers who can then push notifications to farmers, or a farmer could sit with them in their office and like go through different iterations and just come up with some insight about something. Yeah, go ahead.
So you talked about how when you're piloting the tool, you'll have demographic data. I was wondering what type of demographic data you're looking at, and if you are going to be also asking farmers what generation farming they are, to see if that has differing impacts on their decision making.
Yeah, that's a good question too. So when we go and interview these farmers, or when we did in last summer, like we'll usually spend about an hour with them, and the survey will capture everything from the number of people in the household to how long they've been farming, or is this a new piece of land? Do you own the land, or are you renting the land? And so we get into a lot of the demographics through these surveys, and then through regression analysis, we're able to really kind of, for example, with that. With the app, or with the tool, we can. I don't need to fight to find it that hard. But essentially, we can sort of plot like, okay, what types of farmers prefer this type of visualization? Does it tend to be female farmers? Do people with less education prefer line graphs as opposed to tables, or something along those lines?
Hi, thanks for taking the time to talk to us today. I had kind of a two-part question about the process of actually crunching the numbers from the sample. Firstly, do you have any concerns about bias for the farmers that do choose to respond to this versus those who don't? And then secondly, what's kind of the analysis process for dealing with that sample? Are you concerned about any outliers kind of disrupting one specific part of what you're looking at?
Yeah. I mean, so what we do after we select an area, where we feel like would be a good area to sample precipitation wise, we then go in and work with the Ministry of Agriculture, who has essentially lists of people who live in the community, and we randomly select from the lists and just sort of move through, with some sort of algorithm, usually like every third person or something along those lines. And so, we're trying to randomly sample. We're really trying to capture the whole country. But in contrast to here, if I like went around farm country in upstate New York and knocked on people's doors and was like, "Hey, will you talk to me for like 2 hours?" Uh, Here people would probably not take that well to that. In Zambia, like everybody says yes, and so we never have this problem of people like refusing to interview with us, which is maybe a little exploitative as a researcher, but it's culturally very different in that sense. Yeah.
Any more questions? Thank you.
what can we learn from the research you've done about how to better communicate climate change and not seed selection?
And not seed selection?
What
Yeah.
can we learn from how you communicate the conditions for seed selection? but
Yeah.
Apply that to communicating climate change.
Yeah, I mean, well, first of all, there's not much politicization around climate change, particularly in Zambia. And so there isn't this stigma about it. Most farmers have actually, like, they almost have the opposite problem there where they all believe in climate change. And in my opinion, sometimes like over believe in it because they've gotten messages from NGOs and the government, et cetera, about like climate change is happening. What do you know, how are you going to do what are you going to do about it? They're getting messages from the market through these seed companies, like climate's a thing, droughts happening more often, seasons getting shorter. And so they're constantly like, in some ways, I think making these overly conservative decisions about farming, so planting earlier and earlier maturing seed varieties because they believe climate change is impacting them. And one of the things that I'm doing in a way, like in response to the previous question, is like trying to actually show farmers, like, here is what the data looks like. Like climate change is a distant concept. If you want to think about it in the near term, like here's what a model and here's what your weather data is likely to look like. Here's essentially what like the probability of risk is going to look like for you. And so really, I guess to indirectly answer your question, it's like you almost have to customize it to every single person. Like, how do I kind of communicate on your terms with you about climate change? Because at this point, everybody sort of believes it's happening, but how is it going to impact me is more the decision, whereas in the United States, we're constantly, environmental psychologists, et cetera, are constantly wrestling with like, how do I get people to worry about it? How do I get people to believe that climate change is happening? And it's almost like the opposite problem in some ways in other parts of the world. Is that a satisfying answer? Somewhat satisfying?
Done a lot of research about what works and what doesn't work for communication.
Yeah.
Yeah, and I was trying to figure out
Yeah.
how that feedback could be applied more broadly to other disciplines.
Yeah. I mean, I guess if I had to sort of condense some of it, like a lot of what we've found is that just the ways that you communicate have to be tailored to people. And when we think about it very broadly, it just sort of people just gloss over. But if you talk to me in terms of like the probability of a dry spell occurring in the first month of the rainy season is about this amount, or like this is when the season is starting in your village now. This is, in the last 10 years, it's shifted by 4 days. Like this is a way that I can communicate better just in, agriculture terms, because that's all they're concerned about.
Any final questions? Okay, that's thinker.
Well, thank you all for the questions. I just want to put a plug in. I teach a class called Environmental Decision Making. If some of this is interesting to you, please look for my class or shoot me an email. And I also try to involve students in research overseas and here. So seek me out. Thank you.